And so this talk is about Goa. Goa is I don't like to say the word framework because it has such a negative connotation in the Go world, but I would say it's a framework that has three parts. There's a Go DSL that you use to design your API. And then there's a tool that uses that DSL to generate code and documentation. And then there's a library that both the generated code and your code use to actually implement the microservice. So in this talk, I'm going to go over a little bit what I mean by API design, just so we're sure to be talking about the same thing. Then we'll jump right in and write a Goa service. I think that's the best way for all of you to get a better idea of what it does. So I'm just going to stand here and actually code a Goa service. So please be lenient. And then once I've done that and we have a running service, I'll step back a little bit and talk a little bit about the design and code generation principles that back Goa, just so that you understand better how it enables the API design lifecycle. And once we've done that, we'll go through a few advanced topics just to give you a broader sense of what Goa is about. All right, so let's get started with API design. So imagine that we all got contracted and we need to implement a one review app. Now, how cool is that? No? That's the best app ever. And we have a new customer, he's excited, and we want to build a web app for him. So we've decided to do that using a RESTful service to back the app, right? And we've sat down for a little while, thought about it, and came up with those two awesome resources for our service. One is the bottles resource, which is going to represent a bottle of wine, and the other one is the reviews resource, which is the reviews that users of the application write. And we again sit down 5 more minutes. That's pretty much how long it would take to come up with this. And we decide that we're going to be able to create bottles by posting to /bottles, and that we're going to be able to retrieve and list all the bottles by doing a get to /bottles, and then create reviews. And the reviews are bottle specific, so we're going to say that to create a review, you have to post to /bottles /the ID of the bottle and /reviews. And to list all the reviews, we're going to send a get to /bottles /the ID of the bottle /reviews. That should be fairly straightforward. Yeah? Everybody feels good about that design. I mean, it feels pretty solid to me. And then the UX guy come, and that's always bad news. And they tell us, you know what we want? What we need is we need to be able to show all the reviews for a given user, and so for all the bottles that he has reviewed. And we tell him, well, great, simple. Just get all the bottles, index all the bottles, and then for each one of them, get the reviews. Simple. And then UX guy goes back, does that, and next week comes back and tells us, hey, no, that doesn't work. This is too slow. Right? Now, this is the n+1 on-type pattern. Right? Now I'm doing n+1 requests to display on my reviews. So that design does not work. OK, so we go back to the drawing board and think about it and come up with this new design. So now reviews is a top-level resource. Right? You index all the reviews by doing a get/reviews. Yeah, OK, that makes sense. But then maybe we could just filter and get all the reviews for a given bottle and get the same behavior as what we had with /bottles /ID /reviews and get rid of all those APIs. Yeah, that makes a lot of sense. So here's our V2. Now reviews is the top-level resource. We can list the reviews by doing a get/reviews. We can create a review by doing post/reviews. And we can list the reviews for a given bottle by filtering with the bottle ID, passing a query string param. Great. So kind of the point of this example is to show you that designing an API is an iterative process. Right? You come up with an initial design. You go back, and you then ask product, hey, does that look good to you? You ask the dev teams that are going to build other services that sit on top of your service, does that look good to you? And then you go to UX and UI and ask them the same question. And once everybody agrees, like once it looks good for everybody, then you start implementing. And as you implement, you realize that some design decisions you've made don't work, so you have to go back and start again. So it's an iterative process, and the tooling that you use to design the API needs to support that. And designing a good API is really hard. There are a lot of considerations and a lot of people involved in those designs. And there really are two sides to designing APIs. There's the developer side, the team that is actually going to implement the service, and the reviewer side, which is the team that's going to consume, or the architect, if you have an architect in your organization, that would be the reviewer. And so the reviewer needs a specification to be complete. The details are important, right? Consistency is very important in API. So, are you using snake case everywhere or camel case everywhere? All the little decisions are important. And once you've done through all that work and designed an API, now you get to implement it. But as a reviewer, how can I make sure that what we're implementing is what we agreed on? That's another problem. As a developer, then, I have to write all of this, right? All those details, right? I have to write the verbs, the path, the parameters, the description of the payloads, of the responses, and that's just a design, right? Now I need to redo all that work again to implement the API. And I'm supposed to keep that up to date with the design as the implementation changes. That's almost impossible. So the goal of Goa is to enable the best practices when designing APIs and helping both the reviewers and the developers in that process. So with Goa, you design your API in code using the Goa DSL, which means that you get to think about the design as a first-class abstraction, right? You make those decisions we just saw, you make them explicitly in a DSL code. And then from that code, the Goa tool is going to generate the documentation, which means that the documentation is always going to be up to date with the design. And it's also going to generate the boilerplate code so that you know that your implementation implements the design. That makes the reviewer happy. And that makes the developer happy too, because he doesn't have to redo all of that work, right? OK, so let's just jump right in and code. So back to the one service. So TWRS, the one review service. So our customer is fairly technical. He understands Agile. And we go to him and we say, hey, we're going to start with a simple, just with the bottles resource for now. And we'll be able to create a bottle, and we'll be able to retrieve a bottle by ID. And that's going to be the MVP. Great. And a bottle for now is going to have an ID, a name, a vintage, and a rating. I'm going to start with that. OK, sounds good. All right, let's code. Oh, I should have done that before, sorry. OK, is that, can you guys see that? Maybe a bit bigger, a bit better. Is this good? You guys can see that? All right, cool. All right, so let's see, where am I? OK, so oops, sorry. Get there. OK. Let's see if I can make just a little bit smaller. Is this still good? Otherwise, it's going to be too big. OK, so we're going to start by writing design. So as I mentioned, the design in Goa is just code, right? So I'm going to be writing Go code. Now, I'm going to use the Goa DSL. So it's Go code, but it's using a DSL. So let me make sure that I don't cheat and I don't have anything. I don't. Good. So the design folder, which is going to implement our design package, is empty. Right? So I'm going to create a new file in that folder called design.go. And I'm going to implement the design here. So the first thing we have to do, it's Go. So we need to give it the name of the package. And the very creative convention here is to use design for that. Now, before you get to pitchforks, yes, I'm using .import. And yes, I know. And this is just to enable the DSL. So nothing else in Goa, not in generated code, and not in a library, uses .imports. Do not use .imports. This is just to enable the DSL. And for those of you who don't know, using .imports allows me to refer to the symbols defined in the Goa package without having to prefix it with a package name. So it makes a DSL very nice and clean. Okay, now the first thing I'm going to define for my API are the global properties: name, description, title, etc. So here we're going to use a global variable to do that. And we don't really care about the return value, so I'm going to use underscore as the name of the variable. It's a way to tell Go, hey, we don't really care, it's just to call this function. And the name of the function is API. And the first argument of that function is the API name. And the second argument is an anonymous function that allows you to define additional properties for that API. So here, I'm defining a description, and I'm defining the host name. And I'm defining the host just so that the generic code just works. It's just going to be used as default values. You can override it later. So here, we're just going to use localhost for the demo. Great. So we have our API, the global properties of our APIs defined. The next thing we need to do is think about the types. Now, in Goa makes a distinction between input types, types that describe the shape of request bodies, and output types, types that describe the shape of response bodies. In the REST world, these are partial representation of resources, right? But they're representation, so they actually may have different fields, so there are different types. For example, typically when you get something from a REST API, there may be IDs, hrefs, things that you wouldn't use when you actually create the resource, right? So the types are different. Now, oftentimes, there are common attributes. Like in our case, the name of the bottle is going to be used both at create time and when we retrieve the bottle. So the Goa DSL allows you to take advantage of that, but they are different types. So let's start by defining the input types, and that's the type that describes the shape of the request. We've decided that our bottle will have an ID, which is going to be an output thing, so we don't use the ID in the input type, a name, a vintage, and a rating. So we're going to define that here, and to do that, we're going to use a function called type. But we're going to actually assign the result of that function to a variable because we want to be able to refer to it when we actually define the endpoints, right? So, sorry, we're going to call it bottle payload. And same idea, type takes a name as first argument and an anonymous function as second argument. Okay, so here I specify description for my bottle payload. Next, I need to define the fields. To do that, I use a function called attribute. The first argument of attribute is name. That's the name of the attribute. The second argument is the type. The third is an optional description. And the fourth is an optional anonymous function that you can use to define additional things on that attribute. For example, here we're going to define a validation rule. We're going to say that the name has to have at least 2 characters. So here's my attribute name. It's a string. Name of bottle, and what's the end that you don't see here, just say func. It's just to code. Maybe I can make it a bit smaller, no? Can you guys still see that in the back? Yeah? Cool. All right. So here's our attribute name, and we're saying that it has to have a length of at least 2 characters. Great. Now I'm going to define the vintage and the rating attributes, and here I'm going to say the vintage has to be at least 1900. If you have bottle of wines that are older than that, please come see me. I'm very interested. And we're going to put a rating between 1 and 5. Okay. And the last thing we do here, we say that those 3 attributes are required when you send requests to the API. So if the body of the request is missing one of them, it's a bad request. Great, we're done. We've defined our input type. Now let's define the output type. In Goa, what is called a media type. And so we're going to use a function called media type. And again, we want to use it later. So we're going to store it in a variable called bottle media. And it works similarly to type, but there are a couple of differences. One is that a media type can define attributes like types, but can also define views. So the idea is that if you list a resource, you may only want to show 1 or 2 fields, right? But if you show the resource, and you may have an expanded view that shows all the fields. And you don't have to define multiple media types for that. You just define the one media type, and you define a couple of views on it. So here, we're just going to use one view, the default view, just to keep things simple. But there we go. We have our media type. The first argument is the media type identifier. We specify the type name is the anonymous function. And we use this reference keyword that says, hey, some of the attributes of this media type are going to be reused from our payload. So all we'll have to specify for those attributes is the name, and the type and description and the validation rules will all get reused from the payload. So there we go. So we specify the ID. The ID attribute is specific to the output type, to the media type, so we have to specify everything for it. But we just reuse the name, vintage, and rating attributes that we've defined in the payload type. And then we say that all those things are required. Now, that may seem a bit weird, because that's an output type, right? So what does required means? It means that any representation, any rendering of this resource must have non-zero value for those fields, right? Okay, great. So we've defined our types. We defined the input type, the output types. Now we're good. Now we need to define the actual endpoints. And the way you do that with Goa is you first define resources, and then for each resource, you define actions. And the actions are the endpoints. Now, the terms and overall the feel is very RESTful, right? It's very REST. But Goa doesn't actually have a strong opinion about that. A resource is just a nice way to group APIs together and endpoints together that have common properties. Whether it's REST or not, actually it doesn't matter. Okay, so I'm going to define this resource, and the pattern is the same as with the other functions, so it should start to look fairly familiar. The name of the resource is the first argument, and the name of the function is the second argument, a description, and here we specify a base path, which is going to be a prefix for all the requests being sent to the endpoints defined in this resource, right? Okay, so we say that /bottles is the prefix for all the endpoints in this resource. Now we need to define the actions, and we do that using the function called action. And the function action is going to list a few things. It's going to list the parameters that the endpoint accepts, both the path parameters and the query string parameters. It's also going to define the request payload, if there is one. It's also going to define the responses, if there are any, and for each response, which media type to use, if the response has a body. So let's do this. All right, so. Okay, so here I define my create action. I'm saying that the path is post to slash, and that's relative to the base path, right? So it's actually going to be post to slash bottles from a client. The payload is the bottle payload type that we defined earlier, and the response is created, meaning it has status code of 201, but we don't specify a media type, so there's no body for that response. And next, I'm going to define the show action, and this time, there is a parameter, the ID parameter, which specifies the ID of the bottle we want to show, and then the response accepts the media type, so which we defined above. Awesome, we're done. We've designed our API. Now we can have fun and generate code. Okay. Uh-oh. I made a mistake somewhere. Somebody help me. What did I do? Aha. Okay. Okay. Let's see that. Before the action. Bleh. Oh, thank you. Yep, thank you. So it's a real demo. It's very live. What did I? Oh, yeah, that's because I forgot to define the view. Of course, that's why. Oops. Yeah, so let me define the view. So as I said, we're going to just have one view, and it's going to be the default view. And the view is going to list all the attributes it returns. So here we're going to return all the attributes. One view that returns everything. Okay, and now it should work. Yes. Okay. So we've designed our API, and now we can actually generate the code. We do that using the GoaGen tool, which comes with Goa. The GoaGen tool accepts a command, which tells it what to generate. Here we're going to say bootstrap, which means generate all the default code that we need for a new project. And then we're going to pass a flag that gives GoaGen the path to the design package, the import path, right? The Go import path to the design package. Okay, so I run GoaGen, and it does its thing. I don't want to say magic because people don't like that word, but it does seem a bit magic. I will explain how it works, don't worry. And then we see that it generates all of this. At the top, there's this app folder that it generated. That's the app package. That's where all the binding happens between the Go HTTP server and your code. Then it generated main and bottle.go. And this is code that gets generated only once. Okay, so that's a very important point. Main.go and bottle.go only get generated once. At the end of the day, it's your code. GoAgent is just being nice and generating an initial version for you, so you have a bit less typing to do initially, but it's your code, okay? It's not going to override it ever if it's already there. That's opposite to app, for example, which it will get rejected every time from scratch. So that even if you try to put something in there, it will get lost and be regenerate, and that's a good thing. Then there's a tool directory, which contains a command line tool to call this API. Then there's the client package to call this API programmatically, and the tool command uses that to implement the calls. And then there's a Swagger folder with a Swagger specification for our API. So we got all that for free, right, from that design. It's pretty cool. All right, so and it actually builds, because it does generate this initial main.go for us, and I can run it. There, it's running. So I wrote the design, and I'm running my code, and the service is running. I think we're ahead of schedule. The customer is going to be happy. Okay, so now we want to show that to customers. Are we excited? Like, hey, look, it's running already. We're making good progress. But we don't want the customer to have to deal with, okay, what is the path to get to the API? What's the headers have to set, all that stuff, right? So we're just going to give him the command line tool. And let's see what that looks like. So I'm going to this tool directory, which just got generated. And I'm going to build this code that just got generated. And now I'm going to call it. And first, I'm going to create without giving any argument. And I get this nice help, right? It's telling me, okay, there are two commands on this tool. There's a create command to create a bottle. There's a show command to show a bottle. Right? Remember, we implemented both create and show by ID. And then some global flags. Okay, I'm interested in creating a bottle. So let's try that. But I don't really know how it works. I'm a customer, and it didn't give me the docs. So let me do help. So to create a bottle, I have to say, so there's a subcommand called bottle, which is how I'm going to be able to create a bottle. If you had multiple resources, there would be one subcommand for each, right? So you could create blah. So here we're going to create a bottle. Okay. Create bottle help. And to create a bottle, I can specify the path. It's optional. And I can give it flags. And the flags are a content string to override the default content type being sent to the service. Sometimes it's useful to test things. The payload in the form of JSON on the command line. Now, that's just how the command line works, right? The client will encode the payload correctly depending on what you decided to support for your service. But on the command line, we're going to use JSON. And then there's a pretty print. OK, let's try it. So let me try to create a bottle here. But again, I'm the customer. And you didn't tell me the rating had to be between 1 and 5. So I'm going to make this request, but I'm going to specify a rating of 0. So now the client makes the request to our service, got back the result, and the generated code did the validation and returned a nice error message, right, saying, hey, payload.rating must be greater or equal than 1, but got value 0. That's cool, right? I understand that, even if I don't know how this got implemented. Great. So now let me fix that. Let me specify a rating of 1. And now, yep, that worked. Awesome. And if we go back to the service logs, you see that the service got all those requests. I'm not lying to you. This is actually happening. And you can see that there's some information about the details on those requests. I'm not going to go through the details here. Great. Pretty cool, no? So again, the customer is happy. We're making good progress. And now let's step back a little bit and see exactly what happened. How did GoAgent do that? And the idea is that what GoAgent does is it takes your design, which is the DSL that calls those functions, It takes the code that contains the algorithms that generate the output, the final output, and compiles a tool with those two things in it. And that tool runs, and that's the tool that generates the actual output. So GoaGen generates a tool, and that tool generates the final output. Now the customer would like us to actually return something else than 0, and would like us to actually implement this thing, right? But before we do that, I just need to introduce just a few key concepts on the Goa library, just so you're not completely lost when we look at the code. So obviously, in the Goa service, there's 3 kinds of code, right? There's the generated code, there's your code, and there's the library. And both generated code and the your code use the library. The generated code makes code into your code, and your code makes code into the generated code. And if we zoom in a little bit, in the library here, the top-level object is a service. That's what actually implements our API. A service has a MUX, which is the router, right? It has middlewares, which apply to all the endpoints. Individual controllers can also have middleware. And the service also has a decoder and an encoder. And what's cool about that is that they get configured by the generated code. So here we didn't say anything about the encoding in our design, which means we use the default of JSON, XML, and GOB. But you can actually specify in a design consumes, produces, and specify the MIME types that you want to support. And then GoaGen will generate the right code to configure the encoders to do that for you. Then we have the controllers. The controllers are the generated code. There is one controller per resource in our design. The controllers internally have a bunch of handlers. There is a generated interface for each controller, and the handlers are basically the function on that interface. And there is one handler per action in the design. So in our case, we have one controller, and we have 2 handlers. Each handler gets handed a context object, which is specific for that action. Right? So that's the cool part, is that the context object will have data structures that reflect your design. So you don't have to bind, you don't have to convert from string to integer. All of that is done for you. Right? The validation and the conversion has been done for you in generated code. Great. If we take a more dynamic look at this diagram, the request comes from the client to the Go HTTP server, which forwards it to the MUX. The MUX processes out the params out of the path of the request, and then passes all that information to the generated controller. And that's when interesting things happen. The generated controller then creates those data structures that are specific for this endpoint and sends that over to your code. You implement your action, and then you use one of the generated methods to reply to that request. And there's one generated method per response that you define in your design and per view. Great. OK, so now that we understand that, let's go back and implement. So where am I? This is not the right thing. Right? Oops, where did that go? There we go. OK, so I'm going to stop my service, and let's take a look at the generated code. I'm going to start with main.go just because it's a good place to start. So that's the generated code we're looking at. You can see that GoaGen generated a go generate command at the top, so we could regenerate everything just by typing go generate and not have to retype the whole GoaGen command line. And then the generated code imports 3 packages: the Goa package, the Goa middleware package, and the app package, which is the generated code. Next, in the main, what we do is we create our service, right, that top-level object we just saw. We mount a few common middlewares. Now, again, this is your code. This is not going to get overridden, so you're free to change that list and put whatever you want in there. And then we create our controller. We mount it. I'll get back to that in a second. And we start the service. Very simple, and that's it. That's all there is. Now let's go back to this line. That's an interesting one. This is using the generated code to mount a controller onto our service. And if we look at that function here, again, this is generated. It takes 2 arguments. One is the service, and the other one is the bottle controller interface, which is defined just above here. The bottle controller interface defines two functions, which corresponds to our two endpoints. And each function takes an argument which is specific for that action, right? So there's a create bottle context and a show bottle context. And those context object contains data that is, again, specific. So the show bottle context has a field called ID, which is an int. And the create bottle context has a field called payload, which is a create bottle payload data structure that has the fields that we define in our design. So when you get to use that stuff, it's all there. You don't have to do anything. Great. OK, so now let's implement this. I'm going to go back up here into this bottle.go file that was generated. That's also a file that is generated only once. Right? The top-level files get only generated once. And that's a default implementation for our controller. And by default, it doesn't do much. Now, I'd like to remove that, please. Thank you. OK. OK. So it has a function called new bottle controller, which just basically creates the bottle controller data structure that was generated for us, which is empty by default. All it has is a Goa controller anonymous field, which just implement this Microservice interface, which you may have seen in the generated code. This is just to hook up the routes. You don't have to worry about it. Obviously, you're welcome to look at the details. But if you just want to implement, you don't have to worry about it. And here's where the endpoints got generated. So we'll get this create and this show endpoint. And we just want to implement the show here. So I'm going to use this app.bottle data structure that was generated for me. It corresponds to the media type that we define in our design. So it has a field called ID. And I'm going to cheat a little bit here, and I'm going to reuse the ID that was passed in the context. So it's the ID, the show/ID. That ID is an integer, and it's given to me in the context object given to the show method. OK, a name. I'm going to use number 8 because it's an expensive one that I like, and its name is easy to write. And then a vintage, let's say 2012. And then a rating. I like it. I'm going to give a high rating. Great. And the next line here returns this media type data structure using the OK method that was generated on this context object. All right. In our design, we said there's an OK response. It returns a bottle media. So we got this method generated for us. And it will take care of serializing it for us, putting the right headers, the right content type, all of that. OK. So we're done. We're implementing. Now we can rebuild our service and start it again and make the same. We're going to make a show call actually this time. So let me show you that. So we're going to do show bottle and show bottle. There we go. And we're going to pass in an ID of 1 and print the result, please. And there we go. We made our API request to the service. We got back this response with what I just wrote in the code. We're looking good. Our service is implemented. The customer is very happy. We're making progress very fast. Great. So now I'm sure a lot of you are wondering what happens if I change the design, right? And I regenerate everything. Do I lose my changes? How do I adapt my code to the new code that's generated? How does that work? That's always a tricky part with code generation, right? It's the cycle. And as we've seen in the beginning, designing an API is iterative process, so it's very important to do this right. And to explain how that works, I just want to go through a couple of principles that the GoaGen tool follows to enable that. The first one is the one I call code separation principle. And the idea is that generated code and non-generated code never mix. The generated code lives its own package, app, client, and you never put any code in those packages. The only way you use the generated code is through well-defined Go interfaces, right? So it's like if you were using a package that somebody wrote, right? It's the same thing. You can think of GoaGen as an extra member on your team. You're not messing with this code. It's just writing this code in this package, and you interact with it in the normal Go language way of doing that. And what that does is two things. One, it makes generated code cheap because you don't have to maintain it. You don't have to test it. Right? It's just its own thing, completely separate. And two, it makes understanding errors when you change the design regenerate and recompile, very understandable. Right? If you change the field vintage from vintage to year, for example, then you get an error saying, hey, I don't know what vintage is. And you're going to say, oh, yeah, I really mean year. Right? It's going to be fairly intuitive. There's an exception to that rule, which is a scaffold code. Again, there's main.go and bottle.go. And those things are generated once to help you get started, but it's your code. You have to test them. You have to maintain them. Right? This is just to help you get started. The second principle is that GoAgen only generates boilerplate code. Code that is repetitive, boring, that you don't want to write because you're going to make mistakes because you're not interested in it. Right? So that's the whole point of code generation, is to do that work that's boring and uninteresting. So what that means with Goa is generating the marshalling and unmarshalling code, generating those data structures for each endpoint, generating the validation code and the client code. So all those things that are not fun to do if you do them by hand. And the final principle is that generation must be idempotent. So if you don't change the design, or if you change it in ways that doesn't matter, like for example, you change the ordering of the action definition in the design, then the generated code is going to be the same. Exactly the same. So you can do a give diff, and there will be no difference. And actually implementing that is interesting, because one of the things that GoAgen does is generate random examples, while they cannot be completely random. So the trick here is to use the name of the API as seed for the random generator. But so GoAgen makes sure that you can rely on there is no difference if there's no difference in the design. Great. So now our service is implemented. It's running. Our customer is happy, but he'd like to see something a bit more visual, maybe, right? So it's time to get the UI guys to get cranking and have them put something nice on top of our API. But they don't really grok Go, right? And they don't really interested in learning Go. They'd rather have a nice documentation of our API. But they understand Swagger, right? It's a fairly common way of documenting API, right? So we're going to give them the Swagger specification for our API. So to do that, I'm going to stop the service, and I'm going to edit the design, and I'm going to add a new resource. I'm going to call that resource Swagger. Actually, yeah, I'm going to call that resource Swagger. Uh-oh. Did I make a mistake? Var resource Swagger. No, that was good to me. Let's see here. No, I don't want bottle again. I want Swagger, please. Okay, fine. All right, that's going to be challenging. Okay, so Swagger, and please work. No, still no. Okay. So that's a Swagger resource. It has a description. And this time, I'm not using actions, because we are not going to really implement behavior. We're just going to serve static files. So instead of action, I'm using files, which defines file servers. And I'm going to serve two things. I'm going to serve the Swagger JSON, and I'm going to serve the Swagger UI. OK, great. So now we have that. Let's regenerate everything. So I can do just go generate. And that's going to work because GoAgen put that comment at the top of the main.go file. And now that it's regenerated, I'm going to rebuild. Actually, no. Before I rebuild, I need to do something. I need to edit the main.go, because this was generated only once. And I need to mount the Swagger controller, right? There's a new resource. Therefore, there's a new controller. So I need to mount it on my main. OK. And I'm also going to need to copy the Swagger UI files into the current repository, because we started from scratch, right? So just put the Swagger UI static files in here, then rebuild, and then relaunch. Now you notice that, just for 1 second here, make it a bit smaller so you can see that there are two new endpoints that our API is exposing, right? This Swagger UI and Swagger JSON. So these are new things that our API exposes. And if I recompile, so I may have to go back up because, no, actually I don't. Sorry. OK, and if I recompile this, our client, and I run it again, showing the help, there's a new action called download. right? We define file servers in our API, so now we can download those files using the command line tool. Cool. But that's not what we want to do. We want to do something much cooler. We want to look at a browser. So let me go back. Actually, no, it's different here. So I'm going to open the browser and go to the Swagger UI. Now I'm serving Swagger for my local service. It's loading a default Swagger file. What I really want to load, though, is a Swagger file that is served by my service, right? So I'm going to change that and do localhost 8080. And here is our API. Awesome. Pretty cool stuff. All right, so now you can see it's documented. And for each endpoint, you get the full documentation, if I know how to click, with a description of the payload, of the parameters, of the responses. And you can even try it. I can copy this here in the payload field and click try it out. And it's trying. And it's failing because, again, it doesn't validate. But it's working, right? So as the UI guy implementing my service, I can go to this thing and can try things, see what version I get back, and try out my UI and make progress very quickly. So it's very nice. OK, so what we just saw is an example of adding a resource, right? And all I had to do to take advantage of the new code is mount the generated controller onto my service. Let's take a look at a few other scenarios that may happen when you change your design. You could be adding a new action, in which case that's going to add a new function on the API, on the interface it's generated, which means that your code will not compile because your data structure, your controller data structure is not implementing this new function, but the error message that the Go compiler produces will be very clear, right? You need to implement this new action. If you change the types, then what happens is what you would expect. Like if you add a new field, then the new field is available to you. If you remove a field, then the compression is going to fail because the field is not there, et cetera, et cetera. So at the end of the day, when you change the design and you regenerate, because everything is completely independent, the error message you're going to get from the Go compiler are going to make sense to you. Something I want to say very quickly, too, is that GoAgent can actually generate also all those other things. So it generates test helpers, which allow you to do component-level testing very quickly. It generates a JSON schema a la Heroku, and it also generates a very thin JavaScript client to the API, so that UI guy, you can hand them over this JavaScript client, and all they have to do is call the methods, and it will make the correct API call. So stepping back just a little, our customer is super happy. The UI guys were able to implement the API. We delivered on time. Awesome. So what did we just see? We saw that with Goa, the design gets embedded in implementation. The data structures that GoAgent generate, the validation rules that you put in the design, all of that becomes part of the implementation. As a reviewer, I feel good that the code you're writing is going to implement what we agreed on. As a developer, I feel good because I don't have to write this code. The API lifecycle is enabled through code generation principles, so you can change the design, and it will make what happens will make sense. It's nice. And the real-time documentation is really a big boon. Right? You can take that documentation served through Swagger and share that with product, with UX, with other dev teams, and they can just see in real time what the current design of the API is. So the design becomes the single source of truth for your service. OK, so let's go through a few advanced topics. I don't have a lot of time left, so I'm going to go fast. The first one is connecting services. So we saw that GoAgent generates the client. You can take that client and wrap it with your own client that may have higher level abstraction methods, right? So maybe the one method in your client ends up making 3 API calls, but it's nicely encapsulated for consumers, which, especially if it's another service, makes things very nice. Another cool thing you can do is we just had this one design package, but you could split that up, right? And you could put the types in a different package and then share that with other designs. So if you think about a microservice environment where multiple services may share the same types, that becomes very powerful, right? Because now you know for sure that all the types that all the services are using are the same. And here in this example, I'm using a .import again to import a design of a different service, and then using types like here bottle payload that was defined in this other design in my current design, right? That's cool stuff. Another thing you can do with Goa is define your security schemes in the design. And Goa has built-in support for basic auth, API key, JWT, and auth too. And by native support, I mean that you can define those things in design, and you will get code generated in the client, you will get code generated in the service, and it will also be part of the Swagger specification. So documentation will also show that. So here's a quick example. I can define a JW2 security scheme here. I'm going to say that is specified in the header called authorization. And then in this resource here, I'm referring back to the security scheme, and I'm saying all the actions or the endpoints are defined in this resource. They are secured via this scheme, via the JWT scheme. And just by doing that, you get all the code for you. Now, the last advanced topic, which for me is maybe the most interesting one, is the fact that the Goa DSL engine is actually open. And you can take advantage of it and implement your own DSL and generate whatever you want with it. There's a nice architecture behind it that other people contributed to, and you can create plugins for Goa. And one of those plugins is Gorma that Brian Ketterson implemented. And you can see here the DSL is completely different, right? It's defining models, database models with fields. And from that definition, the generated code can take advantage of the API types and create models from the API types, or create API types from the models. So it's very nice. So thank you to other contributors. Some of you are in the room. Thank you. These are, yeah.